Hello, we are on page 11. We are going to be talking about measuring motion. So be sure you have your book out and are ready to get started. So if you need to pause for a minute to get your book ready, then please do so. Okay, let's go through and talk about, I'm going to read through the questions real quick and then we'll read through the stuff. So it says, first off is, what is the definition of instantaneous speed? So that's going to be the first thing that we're looking at, is the definition of instantaneous speed. The next one says they want to give an example of instantaneous speed. And then we want to think of an occupation that would use instantaneous speed on a daily basis. The next thing we want to do is talk about how to calculate velocities. And then how does the frame of reference play a part in determining the velocity? And then by convention, using the word up and right are usually which direction, and left and down are usually which directions in terms of north, south, east, west. So those will be the things that we're going to be talking about. So let's go ahead and get started real quick. And I'm just going to read through and then we'll answer the question. So first off, it says the instantaneous speed of an object is its speed at an instant or a point in time. Because we cannot divide by zero, we cannot use an equation for the speed to calculate instantaneous velocity or instantaneous speed. So there's no formula for this. However, there are tools like speedometers on the car that will measure instantaneous. And if an object is moving at a constant speed, then its instantaneous speed is equal to its constant speed. So if it is moving at a constant speed, then its instantaneous is equal to the constant. So that would be like if you have your, possibly your cruise control on. Okay, so let's just use that piece and start answering a few questions here. So first off, the first one is, what is the definition of instantaneous speed? And so it would be the speed at a given instant. So speed at a given instant. And then if you would also like to put at a point in time. Okay, so again, an instantaneous speed, an example of that would be when I look at my speedometer. So when I take a look at my speedometer, it may say that I'm going right now 65 miles an hour. But in another point, just a few minutes later, I could be going 67. That's telling you what you're going right then, not an average for your whole trip or anything else. It's what am I going at that specific time. Now, a very good example of this is something that we really don't like, this occupation when they do this, and that would be the police or cops. So instantaneous speed that they are seeing is when they use their radar gun. Okay, so when they use their radar gun and they shoot it at you, okay, they're getting instantaneous speed. And so maybe you had, for some reason, just sped up to 75 real quick, just for some reason, you pushed down on the gas and whatever. If at that point in time, that's when they shot you with the radar gun, then they're going to say, I caught you going 75. And it could have been that you had been averaging 65 the whole time, but just for a split second, for some reason, you goosed it and you jumped up to 75. Okay, so again, that would be an example. So it's just like a snapshot, just an instant, just like that, what we're doing. So then the next thing, okay, we're going to go on then to the next set of reading, I guess. So because we're going to talk about velocity. So this says is, how can you calculate velocity? And it says, remember that velocity is the speed of an object in a particular direction. To calculate the velocity of an object, you must first find the speed of the object, then indicate the direction. Okay, so that's going to be our next piece. So how do we calculate velocity? Well, we actually calculate speed. Okay, which, if you'll remember, speed is equal to distance over time. And then, and here's the key part with velocity, and then we add direction. So remember, that's the difference between speed and velocity, is velocity has direction, speed does not. Now then, here's the next piece here. So imagine a person is sitting on the bus, and the bus is traveling at 15 meters per second relative to the street. The person gets up and walks to the back of the bus at 1. How do we determine the velocity relative to the street? So here's an example. Before the person starts walking, her velocity is the same as the bus, 15 east. However, as she starts walking to the back, her velocity is going to increase. So this is where we drew our vectors, guys. So let's say, we'll just draw it, well, I'm going to do negative since it's going that way. So let's say we're going 15 meters per second, but then we start walking the opposite direction. So really, and it says, did it say how much? Yeah, 1 at 1 meter per second. And so really, relative to the street, we're actually going 14 meters per second, and we're still going east. Okay, and maybe I drew my arrows back here, but it doesn't really matter. It's the fact that one's going one way and one's going the other. Okay. So the question says then, how does the frame of reference play a part in determining the velocity? And so this is our next piece here. You can use the positive and negative numbers to figure out if the person's velocity when they're walking on the bus. First, you have to define what direction. Is it in the positive or the negative? So again, positive tends to indicate eastward. Okay, and then negative here, person walking to the back of the bus is moving in the opposite direction, so they're moving negative, and so negative would be, and it doesn't say that here, negative would be considered in this case west. Okay, so how does frame of reference play a part in determining the velocities? So if, I would say if they are moving same direction, we would add. Okay, opposite, slide this up so you can actually see. Opposite directions, subtract. Okay, and then again, that's where our vectors come into play. So then by convention, if I'm going up or right, that would be considered a positive value. And if I'm going down or left, that would be considered a negative value. Okay? So write a summary. So I would say, to summarize, instantaneous, spell that right, E-I-N-S-T-A-N-T-A-N-E-O-U-S, instantaneous velocity, and I'm going to put or speed, is at a given point in time. And then I would put, we need to remember that velocity must have a direction. Okay. And I would put, if we're going the same, we're going to add. And if I'm going the opposite, we subtract. So that's just a little short piece there to help us remember. Okay, so that is page 11. Again, if I went too fast and you needed to pause or slide back and catch something, do that and be sure you have that all filled out.